direct variation, we also have inverse variation. So inverse, it's going to be basically the opposite. So if we had a ratio, the opposite of a ratio is a product. So inverse of variation is a specific relationship in which there is a constant product. So a product means times, it'd be your x value times our y value. So still very similar, or still very simple, except the exact opposite. And then the equation for this is going to be y equals your k, your constant, over your x. So that's a little different. This one is going to be y equals k over x. All right, so to find our constant, all you literally do is you have to take your two order pairs and multiply them. So for this first one,
20.
k is going to equal 1 times 20. Well, what is 1 times 20?
20.
20. So how would I write my equation for this one? If we look up here, y equals k over x, how am I going to write that?
20 over 1?
No.
20 over 20.
Okay, if you remember on the other one, we had y and x stayed the same. So it's always going to be y equals something over x. Y equals something over x.
20 over x.
Y equals something over x. So all of them are going to be something over x, except this one is whatever your constant. So 20 over x. Whatever you get for your constant. If you think about it, you could choose any of your ordered pairs just like previously. 1 times 20 is 20. What's 2 times 10?
20.
What's 4 times 5?
20.
So they all give you the same constant. So for number 2, we'll just use our first one. 1 times negative 28. Well, what is 1 times negative 28?
Negative 28.
So negative 28. So our equation is going to be y equals negative 28 over x. That's all you do for this. So still very easy.
Yeah.
Number 3, I wouldn't choose the first one just because I don't want to have to deal with a decimal. So you could do the second one. So k equals negative 3 times 4. What's that? Negative 12. So that'd be y equals negative 12 over x.
Negative 12.
And then 4. Once again, well, actually, that one's not too bad because it's half. But you could just do the middle one.
Why not be just 6?
K equals negative 1 times negative 6, which is a positive 6. So how would I write that equation? 6 over x. Very good. Anybody have questions about that? Pretty simple? Okay, this next part, and this is the part that gets a little weird. And not really hard, it's just a lot different than what you've been doing. So, it says if the constant of inverse variation is 16, create a table of values to graph this relationship. So we're saying our x times our y equals 16.
1 times 16. Just put a 1 in there.
Good, so we have to make a table. And let's just start from the beginning. What's our easiest? What times what will give us 16?
1 times 4.
1 times 16? Okay, let's go to the next number. What about 2? Can we do 2?
2 times 8.
2 times 8? What about 3? Can we do 3? No, you can't do 3 times anything. Can we do 4? Yeah. 4 times 4. And then 5, nope, doesn't work. 6, that does not work. 7, that does not work. Does 8? 8 and 2. And then what's our last one?
16 and 1.
16 and 1. So basically, because of the commutative property, you can swap your numbers and that still works. So here's our list of numbers. 1, 16, and I want you to go ahead and graph that. 1, if you notice each one of these are done in intervals of 2's, because that's 2, 4, 6, 8. So where would 1 be? Right between the two, good.
Yeah.
So 1 to 16, that would be about right here. Then 2, 8 would be about right here. 4, 4 would be here. 8, 2 would be here. at 16.1 would be here. Once you plot those points, I do want you to connect them to make a graph. So you're going to notice it will do a funky little curve like this. That's one of the ways you know it's going to be inverse variation. But there's a second thing we have to do. So whenever we're doing inverse variation, we have to make two tables. So our second table,
Wouldn't it be negative or something like
very good. Have you done this before?
that? Probably on accident, yeah.
Okay. Yeah. So that makes it, that's a positive 16. Well, there's something else we could do to get a positive 16. What can we do with all these numbers?
Put them negative.
Make them negatives, because we know a negative 1 times a negative 16 is a positive 16. So basically, you're going to make the same exact list, except make them all negatives.
I just guessed. I didn't know. I think I did it on accident on Desmos, because what we're doing, I've seen it before. It was,
Yeah.
so I did it on accident. So I don't know. I learned that by myself.
Okay. So yeah, we know, we were taught whenever we were taught negatives that negative times a negative equal a positive. So that's how that works out. Because each one of those, whenever you multiply them, they will equal a positive 16. So now we've got to plot these points. So negative 1, negative 16 would be about right here. Negative 2, negative 8 would be about right here. Negative 4 would be here. Negative 8, negative 2 would be here. And negative 16, negative 1 would be here. So what do you notice about that? Same shape. What's it called, though? Do you might remember what that's called? It does start with the R. It's a mirror image.
Reflection.
Yeah, that's a reflection.
Okay.
So,
You can like fold it, you know, like.
yeah, exactly. So whenever you're graphing inverse variations, you should make a reflection of each other. If you do not make a reflection, you know you've done something wrong. All right?
You run big dog.
So does everyone get that?
Yeah.
Is anybody still copying that?
No. This is like the easiest thing we've done.
All right. So 5 and 6, I want you to try on your own. But what do you notice about number 6? I'm going to get you started on this one. Let's make I'll make the tables here.
It's already negative.
Oh, but it's negative. So
It's
that-
negative. So that means all of one of the numbers are going to be what?
Negative.
Negative. The other one's going to be
Positive.
positive. So let's just think about 36. Well, we know 1 and 36. There's not 36 on this graph, so don't even worry about putting that one. So let's start with 2. I'm going to make all my x's positive this time. So 2 and what gives us negative 36?
16.
Not quite. Huh? Yeah, negative 18. Then 3. And guys, if you're ever unsure about what goes into this,
Desmos.
yeah, just pull up your Desmos. Let's try each one. Negative 36 divided by 3. Okay, that works. So 3 and negative 12. Then we do negative 36 divided by 4. That gives you negative 9. 5, we already know 5 doesn't work because 5 has to end in a 5 or 0. So let's try 6.
That's like 5.
Oh,
And then at this point, you know you have used all the numbers, so now you can just reverse it. So now we're going to put 9 over here, negative 4 here, 12 over here, negative 3 here, and then 18 over here, and negative 2 here. And you don't have to put every single one of those points. You need to have at least a good 3 points. So I'm going to start with 2, negative 18. See, 2, 1, 2, negative 18, that'd be here. And then I'm going to choose a middle one, 6, negative 6. So 6, negative 6, that'd be here. and then 18, negative 2 here. So you can kind of already tell at this point what it's going to make. So you do not have to put every little point. If you want to, just to be exact, you can. It's a good habit to be more exact, but that's a lot to do. Okay, so what do you know the other graph is going to look like for this one? Instead all the y's being positive, what your other graph is going to look like? Yeah, so sorry, I said that wrong. Instead of all your y's being negative, on the other graph your y's are going to be positive, and your x's will be what? Negative. So now let's make that list again. Except like I said, you're making this side negative, negative 2, negative 3, negative 4, negative 6, negative 9, negative 12, negative 18. Then this side's going to be positive. 18, 12, 9, 6, 4, 3, 2. All right. So y'all go ahead and finish that one up and do number 5 as well.